Right, okay, here we go. Session 14. We're continuing with differentiation today, and we're looking at tangents and normals. So here we go. Right, so the first thing you need to know is what is a tangent and what is a normal. So if I was to draw a curve, so something like y equals x squared, something like that, y equals x squared, any curve we want, the tangent would be the line that just touches the curve and carries on. Okay, so it just touches the curve. An example, if that was say at 2, we would say that is the tangent at x equals 2. Tangent at x equals 2. Okay, it just touches the curve and it has the same gradient as the curve at that point. So the tangent has same gradient to the curve at wherever you want, but in this case x equals 2. Now the normal, if I change the colour, the normal is the perpendicular to the tangent. So this would be the normal. Okay, so the normal, we say the normal is the perpendicular to the tangent. So the normal is the perpendicular line to the tangent. Okay, so the gradients, you need to remember that to work out perpendicular gradients, they times to -1, but we'll come to that in a minute. Okay, so that is what a tangent is, that is what a normal is, and we're trying to work out the equation of tangents and the equation of normals today. And we're just going to go straight in with an example, so EG1. So we have a curve, y equals x squared plus 1 over x, and the question is find the equation of the tangent at the point to 4.5. Okay, so we've got a curve, y equals x squared plus 1 over x, and we've got to find the equation of the tangent at the point to 4.5. Okay, to work out the equation of a tangent, I need to work out step 1, the gradient. Now, from the last session, you'll know that the gradient is also known as dy dx. So I've got to work out dy dx for this function. So if y equals x squared plus 1 over x, you did last time's session, you need to make that x squared, that's the same as x to the -1, and then I need to differentiate it. So dy dx is equal to, that's going to be 2x, that's going to be minus x to the -2. I can also rewrite that as 2x minus 1 over x squared, which is sometimes easier to deal with. So that's what the dy dx is. Okay. Right, I know my x coordinate. When x equals 2 has come from here, dy dx equals 2 times 2 minus 1 over 2 squared, which is 2 times 2, which is 4, minus a quarter. So it's going to equal 3.75. That is my gradient, dy dx. So I've really done the hard bit now. My equation of the tangent, my tangent is going to equal y equals 3.75x plus c, and I use my coordinate right back at the start. I know that y is 4.5 and x is 2. So 4.5 equals 3.75 times 2 plus c. So I can work out 4.5, 3.75 times 2. This could be a non-calculator paper, so I need to be able to double that. That's going to be 7.5. Okay, plus c. C is going to equal -3. So my final answer, y equals 3.75x minus 3. And that is the equation of the tangent. We'll check this in a minute, right at the very end, because the next part of the question is to find the normal at the point same point. So part B, find the normal of the same curve at the same point, which was 2, 4.5 at 2, 4.5. Okay, so I know the gradient of the tangent. I've already worked that out. Gradient of tangent is 3.75. So the gradient of the normal is the negative reciprocal. Negative reciprocal, so it's 1 over 3.75 and it's negative. Okay, so it's 1 over 3.75 and it's negative. So I might just tidy that up a little bit if I get my calculator out. So 1 divided by, let's go, 1 divided by 3.75, 4/15. So I'm going to leave it as a fraction, negative 4/15. So the normal will be y equals negative 4/15 x plus c. I know, and I use the same point again. So my y, 4.5 equals negative 4/15 times the x coordinate, which was 2, plus c. And if I rearrange this, so 4.5, that's going to end up being equals minus 8 over 15 plus c. So 4.5 plus 8 over 15 equals c. If I do that, plus 4.5, well, let's decimal maybe, well, 143 over 30, so c equals 143 over 30. So my answer will be y equals negative 4 over 15 x plus 143 over 30, and that's the equation of my normal. Okay, now let's just double check this in Desmos to see if it does look about right. So you can always check using a graphing calculator if you've got one, or just have a look on desmos.com. The equation of the line was y equals, I think it was x squared plus 1 over x, and it was the gradient at 2. So if I look at 2, if I drew a tangent there, that is definitely a positive gradient, which is what I wanted, and the negative and the normal has a negative gradient passing through about. So this one passes through about negative 3, which was right, and the normal passes through about 4.5, something like that. So if I check on my, so 143 over 3, it's about 4.7, which is about where it crossed the y-axis. So I know that's going to be probably almost certainly correct. Right, okay, it's practice time for you. Page 219, exercise 8C, and I just want you to see the evens. It goes on a couple of pages as well. Question 2 to 10, well, 2 to 10. So 2 to 10 inclusive, all the even questions, and see you for session 15 next time. Thank you very much.